Good evening, online students.
Good
Ananya,
evening.
yeah, Meera, Rajeshwari, Ram, Sashmeen, and Shreyas. Good evening, children.
Good evening, ma'am.
Good evening. So we'll pick up from where we stopped in the last class. So this is the revision program, not the regular class. So we are continuing with circles. The regular class, we are doing volumes and surface areas, but this is the revision program. So this is session 6 of the revision program. We started circles in the last class. We are continuing with that. I think we finished this one in the last class, right? Yes, I remember. This is done, right, children, in the last class? Circles. This one not done,
Yes,
correct?
Yes,
Yeah, this is
Yes,
not
ma'am.
done. All right. Okay, so from the figure, find angle OTP. From the figure, find angle OTP. OTP. Find this angle. You need to find this angle. All right. Now let's, we'll not write anything, children, as we normally do. I'll explain everything. I'll share the pictures on WhatsApp. Please complete it at home. All right, we'll only understand the session. Please complete it at home. I'll send all the images on WhatsApp. All right. Now going down to 9th standard. The angle subtended by an arc at the center. See here? We have seen this in standard 9. Circle, arc AB. Arc AB subtends, oh, sorry. Arc AB subtends angle AOB at the center. Arc AB subtends angle AOB at the center. The same arc AB subtends an angle ADB at the point D on the circumference of the circle. Arc AB subtends angle AOB at the center. The same arc AB subtends an angle ADB. AOB, ADB. It's rhyming, right? AOB, ADB. These two angles are made by the same arc AB at two different points, one at O and the other at D. D is a point on the circumference of the circle. O is the center of the circle. Now we have learned a relation between these two angles. The angle at the center is double the angle formed on the circumference. To tell you the theorem in short, the angle formed at the center is double the angle formed on the circumference. Is it fine? This is the relationship. The angle at the center is double the angle formed on the circumference. This is the relation. Now let's apply this in the figure. In the figure, we have, what is this angle? What is the angle? PBA. Okay, that angle is called angle PBA. Angle PBA is 30 degrees. PBA is 30 degrees. So from this angle, from the name of this angle, angle PBA, which is the arc that subtends the angle? Which is the arc that subtends the angle? PA is the arc. PA is the arc. And which is the point on the circumference? Which is the point on the circumference? B. B. The arc PA. See here, the arc PA subtends angle PBA at the point B on the circumference of the circle. Yes or no, children? From the name you can make out. See, you can even call that angle ABP. You can also call it ABP. Is 30 degrees. So AP or PA is the arc. AP or PA, both are the same. That's the arc. This is the arc. And the point on the circumference is B. B is the point on the circumference. Angle ABP is 30 degrees. Now, the same arc makes AOP at the center. See here? AOP. AOP, ABP. AP, AP. Same arc. O is the center, B is the point on the circumference of the circle. So there is a relation between these two angles, AOP and ABP. Correct? And the relation between these two angles is that Angle AOP is double angle ABP. AP is the arc. Both are made by the arc AP. This is at the center O, this is on the circumference at B. So angle AOP is equal to 2 times 30 degrees. So the angle at the center AOP is equal to 60 degrees. So we found AOP. The angle at the center we found very easily. This is 60 degrees. Now we know that this angle is a right angle because OP is the radius. OP is the radius and this one is a tangent. PT is the tangent. PT is a tangent at P. OP is, see here, AP is not the radius. AP, online students, my screen is visible, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, okay. I should have asked you earlier, I just forgot. So, in the circle, AP is not the radius. OP is the radius, correct? OP is the radius and PT is the tangent. So, by the theorem, we know that OP is perpendicular to PT because the tangent and the radius through the point of contact are perpendicular to each other. Okay, so this is 90 degrees. Very carefully you should mark this is 90 degrees. Now these two angles, you know in which triangle, 1 second, I'll ask somebody. Yes, you, Priyanka. Now this 60 degrees and 90 degrees are two angles of which triangle? OPT. These are the two angles of the triangle OPT. Can you find the third angle of this triangle? How much? Tell me the answer. Degrees. So which is 30 degrees? Name the angle which is 30 degrees. 3 letters. Use 3 letters and tell me. OTP. And what is that we have to find? We found OTP is 30 degrees. All right. So how do we do this? How do we do this? This is 30 degrees. So this is 60 degrees. Then radius perpendicular to tangent. So this is 90. And in triangle OPT by angle sum property, this angle is 30 degrees. All right. That's what you see here. Priyasha, were you there when I started explaining this answer, Priyasha?
Yes, ma'am.
All right. I'll send the pictures, children. Don't worry. I'll send it. So exactly what I explained is what you see here. So you can see angles subtended by arc PA at O and B. You can say arc PA or arc AP, both are the same. So see here, first we found 60 degrees, the angle in the center, then 90 degrees. And then angle sum property, we got 30.
Ma'am.
Oh, yes, yes, who's that?
Ma'am, Ananya, ma'am.
Yes, Ananya.
In the same sum, can we use BP as the common arc?
1 second. In the same sum, can we use?
BP as the common arc. For BOP angle is twice of BTP.
B?
BOP, angle BOP will be twice the angle BTP directly because they are subtended by the same arc.
BTP, is it, Ananya?
Yes, ma'am, which is also equal to OTP, which is the one we have to find.
Okay. Is T a point on the circumference of the circle?
No, ma'am.
So this, see, okay, it doesn't work. You saw that. And T is not a point in the circumference of the circle. So you cannot use, the theorem is not used like that. 1 point. So there is an arc. It should make an angle at the center. And it should also make an angle at a point on the remaining part of the circle. This point T should be on the circle, not outside the circle or inside the circle.
Okay.
So B angle, you said angle BOP, is it? BOP is equal to twice angle BTP. This is what you said, right?
Yes, ma'am.
Yeah. So BOP is correct. This is the angle BOP made by the arc BP at the center O. That's fine. Now this BOP and BAP can be related. This one. BAP. Angle BOP is equal to twice angle BAP is correct. You are applying the theorem correctly. Angle BOP and angle BAP, because both are made by the arc BP, one at the center and one at the point A on the circumference of the circle. So T is a point lying outside the circle, so the theorem cannot be used with angle BTP. Am I clear,
Okay.
Ananya?
Yes, ma'am.
Yeah. From the figure, find angle AQB. From the figure, find angle AQB. AQB. This one. This one is angle AQB. This is angle AQB. All right. Now, can you see parallel lines marked? This one is parallel to this. These two lines are parallel to each other. You can see the arrow here. These are parallel lines. So see here, parallel line, transversal, parallel line. 8th standard, that's what we have learned. Alternate angles are Z-shaped angles like this. These angles are equal. Alternate angles are equal. These angles are equal. Alternate angles are equal. These angles are equal. Alternate angles. These angles are equal. Alternate angles. These are the two parallel lines, and this is the transversal. These are the parallel lines, transversal. Parallel lines, transversal. Parallel lines, transversal. Alternate angles are equal. So see here, parallel line. Let me just make out that Z. That Z, parallel line, transversal, parallel line. Correct? Can you see this angle 70 here? So this is equal to 70, correct? Parallel line, transversal, parallel line. This is 70, so this is 70. Alternate interior angles are equal. So this is 70. Sorry? Sorry? 55. Which is 55? AQB, you're telling the final answer, is it? We have not still come there. Yeah, we have not still come there. Yeah. So what's the first part, children? What's the first part? PQR is equal to angle QBA. So these two angles are equal. Alternate angles are equal. Now recall that alternate segment theorem. Alternate segment theorem. Okay. So by that theorem, you need to identify a chord and a tangent. To use the alternate segment theorem, you need to identify a chord and a tangent. So we are going to take up the chord AQ and the tangent PR. Correct? We're going to take, to use the alternate segment theorem, you need to take up a chord AQ and a tangent that goes through the, goes through one of the endpoints. AQ is the chord, right? AQ is the chord. The endpoints are A and Q. And you can see that Q is the point of contact of the tangent. You should choose the tangent like that. Which are the endpoints of the chord? A and Q. Now, through this endpoint Q, you can see the tangent PR. In fact, Q is the point of contact of the tangent, correct? With the circle. So we are considering that a chord AQ and the tangent PR. Now the chord AQ subtends an angle ABQ. I told you the point is B. Join the ends of the chord to B. Join A to B. Join Q to B. This is the angle. This is 70 degrees. Now, this is the major segment. This is the major segment. Leave that. This is the alternate segment. This side is the alternate segment. This side is the alternate segment. This is the chord. This is the tangent. So this angle is equal to 70 degrees by the alternate segment theorem. By the alternate segment theorem, these two angles are equal. This theorem was told to you in detail in the earlier session when we started circles. Okay, so this is the chord AQ. This is the tangent. This is the tangent. So this angle is equal to this angle by the alternate segment theorem, because this is the chord, this is the tangent, and this is the angle between the chord and the tangent. In the minor segment, this is the minor segment. This is the minor segment. Now, this is the major segment. This one is the major segment. The other part of the circle is the major segment. Now, the chord AQ subtends ABQ at the point B in the major segment. So this angle is equal to this angle. So this is also 70 because this is 70. Now, we need to find this angle, right? Because AQB. How do you find that? Sum of the angles on a straight line is equal to 180 degrees. The sum of all the angles on a straight line is 180, and hence this is 40 degrees. 40 degrees. So we used two ideas here. Idea one, no, okay, we used two things here. Okay, so one is the concept of parallel lines. Alternate interior angles are equal. So parallel line, transversal parallel line, this is 70 degrees. Then the concept of alternate segment theorem. Okay, so this angle is equal to this angle, Kanishka, you missed the first class. So you see the recording, you will understand. Okay, see you also watch the recording and complete all the sums in your notebook. It will be clear. Okay, so this angle is equal to this angle. So this is 70. Now on the straight line, you have 70, this angle and 70. Okay, so this is 40 degrees. The required angle AQB is 40 degrees. Online students? So you can see here, alternate segment, and it's in the alternate. Okay, I've used a different angle here, that's all. Okay, fine. I've used a different angle. I've used a different chord. I'll tell you this also. I've used with this angle itself. So anyways, we have to use the alternate segment theorem, alternate interior angles, and then sum of the angles on a straight line is 180 degrees.
Ma'am?
Yeah?
Ma'am, we can also use the radii is perpendicular to the tangent, so we can keep it like 90 degree here and there. So 90 minus 70 here, 20. So here also it applies. So 20 plus 20 we can use like 40 degree.
Correct, but you should prove that these two triangles are congruent to each other.
Okay, ma'am.
For that to say that if this is 20, this is also 20. Fine, but to say that these two angles are equal, you need to prove that these two triangles are congruent to each other.
Okay, ma'am.
Yeah. Can we say that they are congruent to each other? Yes, class. Can we prove that these two triangles, with the information given, can we prove that these two triangles are congruent to each other? Think about it. Fine. I'll wait for 2 minutes. Please think. If you can prove that the triangles are congruent to each other, yes, you can use what Meera just told us. See if we have, see the triangles are maybe congruent to each other, but you should have information to prove that they are congruent, right? They may be congruent, but you should have the information to prove that they are congruent. Simply, we cannot say that is also 20. You can show that they are congruent and then say that it's 20. No. We can do like this also. The triangles are congruent. So I believe in applying new ideas like now this alternate segment theorem is new to you. You can also do it like this. Sorry. No, but. Okay, I'll tell you. Yeah. Now, all of you think if you can prove that the triangles are congruent to each other. Yes. Think and tell me 3 things, not 1. You must say 3 equalities that satisfy a congruence criterion, correct? You need to tell me 3 equalities that satisfies a congruence criterion. SSS, SAS, AAS, ASA or RHS. Yeah. Yes, Meera? Is it possible to show that the triangles are congruent to each other?
Ma'am, I find one that QL is common and L is a altitude, so it's 90 degree.
It's not given, no, we cannot assume it's the altitude.
Yeah.
We cannot assume it's the altitude. Okay, so I'll tell you. Okay, so I'll tell you how to prove that the triangles are congruent to each other. Again, you need to go down to 9th standard. We have learned that a perpendicular from the center to the chord bisects the chord. The perpendicular from the center to the chord bisects. If you draw a line from the center to the chord, it bisects the chord. Just a minute.
Ma'am, you are muted here.
Ma'am, you are on mute.
Yeah. Yes, children. No, I was telling you that I did not notice it's not 90 here. If it was 90, then you can say that OL is perpendicular to AB. OL is perpendicular to AB. A perpendicular from the center to the chord bisects the chord. Perpendicular from the center to the chord bisects the chord. Then you can say that, this is 90 degrees. Okay, this is the common side. QL is the common side. This is 90. And because the chord is bisected, AL is equal to LB. And that would make SAS. That would make SAS. Maybe I can just go back to the figure and see if it is given it's a right angle here and then get back to you tomorrow. So for now it is this. So what I have written here is I've used this angle itself. I've used angle BQR itself. So by using the same theorem, BQ is the chord, PR is the tangent. And this is the angle in the minor segment between the chord and the tangent, 70 degrees. So this angle is equal to the same chord BQ subtends this angle in the major segment. This is the major segment. This one is the major segment. The same chord, see, join the ends of the chord to that point A. To this point A, join B to A, join Q to A. So you can see that this angle is equal to this angle. This is also 70 degrees. That's what I've written here. That's what I've written here. Here what I've done is I've used this angle itself. This is the chord. Q, through this endpoint Q, we have this tangent. This is 70 degrees. This is the minor segment. So this is the alternate segment, which is the major segment. And you can see the point is A in the major segment, join Q to A and B to A. Q to A, B to A. So this angle is also 70 degrees. So I found using this angle, I found this angle. And then I've mentioned that these two angles are alternate angles, so they're equal. This is 70, no? So this is also 70. Alternate angles are equal. And then the sum of these three angles is equal to 180. Okay. I'll send the pictures, children. Yeah. Yeah, now think about this and tell me how do you find angle PQB? PQB. Yes, find PQB. PQB. PQB, this angle. Okay, may not be PQB, but can you find any angle here? We have to find PQB, but can you find any other angle? Any angle? Q
Ma'am, angle PRQ is 58 degrees.
angle?
PRQ.
PRQ is how much?
58 degrees.
By the reason?
They lie on the same mark. PQ.
By the alternate segment theorem, right? Shreyas. Okay.
Ma'am,
Not using. Yes, Meera.
we can join OP, no, ma'am. So
No. Okay, fine. We'll do that. My question is, can we find? Tell me any other angle in this figure. Any angle in this figure.
Ma'am,
Yes.
RPQ is equal to 90 degrees, ma'am. Angle in a semicircle.
Very good. That's what I was
yes,
expecting.
that is
Very
only-
good. Very good. Angle in a semicircle is a right angle. That was what I was expecting. So because see, you should look out for the diameter. You should look. See, there's a diameter here. So diameter. When you see the diameter, you can apply that theorem. Angle in a semicircle is a right angle. Circle, 9th standard. This is circle diameter. How do you know it's a diameter? Because it passes through the center O. Because it passes through the center O, it's a diameter. QR is the diameter because it passes through the center O. So P is any point on the circumference. If you join Q to P and R to P, this is 90 degrees. Angle in a semicircle is a right angle, 9th standard. See, I'll tell you again. Circle. This is the diameter. R is the diameter because it passes through O. There is a point P on the circumference of the circle. Join the ends of the diameter to the point P like this. Then this angle is 90 degrees. Angle in a semicircle is a right angle. And then I think Shreyas was trying to say, so this is 90 degrees. By the alternate segment theorem, this is 58 degrees. Then how will you find PQB? PQB, this one. Angle some property. Sorry? Yeah, okay, whatever. Yeah, 32 or yeah, 32 degrees. Correct. So this is the chord. This is the chord. QP is the chord, and at P we have this tangent AB. At P we have this tangent AB. So this 58 degrees is an angle between the chord and the tangent. This 58 degrees is an angle between the chord and the tangent. Now leave this segment. This is the 22, is it? Sorry. Okay, so this is the minor segment. Leave that. This is the major segment. This is the major segment, and this is the point on the circumference of the major segment R. Join the ends of the chord Q to R and P to R. So this angle is equal to this angle. So if this is 58, this is also 58. Alternate segment theorem. And this is 90 because the angle in a semicircle is a right angle. So by using angle sum property, you can find this one. All right. So first I've mentioned angle in a semicircle is a right angle. And then alternate segment theorem, PRQ is 58 degrees. And then by angle sum property, is it 32 or 22? By angle sum property, this is 32 degrees. Yes, children. Try this. See, this is 90 degrees, but it doesn't look like that. This is 90 degrees, but it doesn't look like that, but it is 90 degrees. This angle is 90, but this is an acute angle. It looks like an acute angle. It's 90. It is 90. Find the radius of the cell. All right. So remember that square idea, okay? Always proving that a rectangle is a square. We normally do that in circles. In this chapter, in some questions we come across that situation where you'll have to prove that a quadrilateral is a rectangle and the rectangle is a square. In circles, in some answers we come across that situation where we have to prove that a quadrilateral is a rectangle and the rectangle is a square. So see here. Now we'll prove that this quadrilateral is a rectangle, but we don't see a quadrilateral at all. So first we'll have to join OA. Let me do it here. Join OA. Okay, join OA and no, so I'm not getting it anyways. It's not looking like a square, but it's not looking like a square, children, but Please adjust. Now, if I prove that OAPB is a square, don't laugh at me. The figure doesn't suit the information given, but it is true. The situation can be true. I'm going to now prove that OAPB is a square. Well, it does not look like a square. Okay, but we'll prove it's a square. Now, so join OA and OB. That's the first thing. Now we have this quadrilateral OAPB. Now this quadrilateral OAPB is a rectangle. Yes, I think you all know that. Why is it a rectangle? Online students, Priyasha, find all the angles of the quadrilateral OAPB. Priyasha.
Yes, ma'am.
Yeah, please find the other angles of the quadrilateral OAPB. This is given to be 90.
Yeah,
This is
OAP
90.
is also 90.
Okay. Then
OBP is also 90.
reason?
Tangent perpendicular to radius.
Very good. Tangent perpendicular to radius. Simple words. Okay. Yeah. Then what's the measure of this angle, Priyasha? The fourth angle?
I'm not sure, ma'am. I guess it's also 90.
And this angle, this angle. What is the measure of this
90,
angle?
ma'am. 90.
90. By the angle, some property of a quadrilateral, this also has to be 90 because 90 plus 90 plus 90 is 270. 360 minus 270 is 90. So the fourth angle is also 90. So all the four corners or all the four angles of this quadrilateral OAPB is equal to 90 degrees. Only in two quadrilaterals, we have all four angles 90. They are rectangle and square. In a rectangle and in a square, all the four corners are right angles. So now this one is a rectangle. You can't directly say it's a square. It's a rectangle. Now you'll have to prove that it's a square. So who can tell me, online students, who can tell me, how do you show that it's a square? How can you show that the quadrilateral is a square?
Ma'am, by showing that the non-parallel sides of a quadrilateral are equal.
Yeah. So the adjacent sides are equal. The adjacent sides are equal. Now, is AP equal to BP? Is AP equal to BP class? Why? Tangents from an external
Tangent
point.
from the external point.
Tangents from an external point of the circle are equal. Is OA equal to OB? Radius. So you can mention, yeah, radius. You can mention any one of the two. You can mention any one of the two. So first join OA and OB. Then then find the angles of the quadrilateral. So this is 90, this is 90, and hence the fourth angle is also 90. So therefore, OAPB is a rectangle. In the rectangle OAPB, one pair of adjacent sides is equal. That is, you can say AP is equal to BP, or you can say OA is equal to OB. Any one you say. So in a rectangle, when one pair of adjacent sides is equal, it is a square. In a rectangle, when one pair of adjacent sides is equal, it's a square. So now OAPB is a square. And what is the property of a square? All sides are equal. And what is PA? PA is 4. All sides are equal. Then how much is OA? OA is also 4. OA is also 4. So that's how we find the radius of the circle. You can just read this.
Ma'am,
Yeah.
can we solve the same sum using trigonometry?
Using trigonometry. Yeah,
Yes,
let's try together. Tell me your idea.
We join
Join.
AC and BC. Ma'am.
Yeah. Join. Join which
AC and
one?
BC. Radii
AP and-
both. AC and BC. Ma'am.
You understood what he's saying? Join.
We are joining AC and BC, ma'am.
Ah, that we done. Okay, yeah. After that, yes.
We are taking angle CAP is 90 degrees by as radius is perpendicular to tan.
Yeah.
Then we are joining P to C, ma'am.
C to P. Oh yeah, C to P. Yeah. Then
Then the angle divides into 45 and 45 as it passes through this.
why is this 45, children? Why is the angle 45 degrees? Equal tangents are equally inclined to the line segment joining the center and the external point. Equal. We did this in class, the first class, correct? Equal tangents. What? Did I mention that or no, children? Equal tangents are equally inclined to the line segment joining the center and the external point. Did I mention this or no in the first class? One of you save me.
Yes, ma'am.
Mention it.
Yeah. Thank you. Yeah. So yes, it is 45 degrees. Perfect. Yes.
Ma'am, then by the ratio tan 45, we get AC is AP.
Tan 45 is equal to opposite by adjacent. Tan 45 is equal to opposite by adjacent. Opposite AC by adjacent AP. So 1 is equal to AC by 4. AC is equal to 4. All right. So what you have to do? You'll have to join. You'll have to join OA and join OA and OB. And then you don't have to find any other angle there. You don't have to find any angle at all. Just join OP, and then say that equal tangents AP and BP are equal tangents. So equal tangents are equally inclined. Equal tangents are equally inclined to the line segment joining the center and the external point. Please watch the first recording if you're, because I told you many a times, I told you very clearly in the first class, we recalled all the theorems based on circles, even from standard 9. So please go to that recording. So that way, so since this angle is for 90 degrees, it's bisected. This is 45 here and 45 here. Now take any one of the two triangles. You can take this triangle or you can even take this triangle. You can take any one of the two triangles. You can take any one of the two triangles. This is 45. This is 45. Because you know, PA is 4 means PB is also 4, no? Because tangents are equal. So you can take up any one triangle. You can take up this one or this one, anything. Now, when you take this triangle, this is 45 degrees. Oh yeah, you have to find this angle because only then it will be a right triangle. You need to have a right triangle, right, to use trigonometry. So you have to find this angle then. You have to mention that this angle is 90 degrees. Only then AOP will be a right triangle. So in right triangle AOP, this is 90 degrees because radius perpendicular to tangent. So in right triangle AOP, we are using the trigonometric ratio with respect to the acute angle 45 degrees. So tan 45, because tan only will connect the opposite and adjacent side, which is the hypotenuse. OP is the hypotenuse because it's opposite to the right angle. OP is the hypotenuse because it is opposite to the right angle. So the opposite side is OA, the adjacent side is AP. OP is the hypotenuse. It's not the opposite or the adjacent side. The hypotenuse cannot be the opposite side or the adjacent side. Hypotenuse is hypotenuse. The remaining two sides only can be the opposite and adjacent sides. So for 45 degrees, OA is the opposite side. Tan 45 degrees is equal to opposite OA by adjacent AP. OP cannot be the adjacent side because it's a hypotenuse. So AP is the adjacent side. Tan 45 is 1. OA is equal to OA only because we do not know. AP is 4. On cross multiplying, OA is equal to 4 centimeters. Very good, Shreyas. All right, children. Yeah. Very good. How? Very good. So Kanishka here gave us the correct answer. So P is the external point for both the circles. P is the external point for both the circles. P is the external point for both the circles. PQ is equal to PT for this circle because tangents from an external point of the circle are equal. Then PT is equal to PR for this circle. Same reason. Tangents from an external point of the circle are equal. P is a common outside point to both the circles. So PQ is equal to PT for this circle and PT is equal to PR for this circle. Okay. Now what is given? PT is 3.8. If PT is 3.8, PQ is also 3.8. Again, if PT is 3.8, PR is also 3.8. Tangents are equal. So QR will be QP 3.8 plus PR 3.8, which is 7.6 centimeters. Very good. Kanishka. Kanishka gave us the answer for this one. Understood, children? Online students?
Yes, ma'am.
Yes, ma'am.
All right. That's what I've written here. Yeah. Find B80 if AOB is 100. Find B80. Okay, let me ask you questions to find the answer for this one. Now, give a special name to the triangle OAB. Isosceles triangle. Why? Which are the two sides equal? OA is equal to OB, correct? OA is equal to OB. Always watch out for that. OA is equal to OB because radius. So it's an isosceles triangle. OAB is an isosceles triangle. OAB is an isosceles triangle because these two sides are equal. Now, which is what can you do next? What can you find next? Yeah.
By angle sum property.
Okay, she said 90 degrees, correct. OAT is 90, you're saying, is it? Very good. Meera, yes?
Ma'am, by angle sum property, we can find that A and B, but
Yeah.
100 2A to x is equal to 180, 2x is equal to 80, x is equal to 40.
Yeah,
Then we
correct.
can use that OAT is 90 degree and find angle BAT. They are asking BAT, so 90 minus that 40 degree, we can get 50
Very
answer.
good. Very good, Meera. So, who told us about the triangle? Not getting your name. Suddenly, my brain is frozen. What's your name? Huh? Nandini. Nandini. Oh shit, what's wrong with me? Nandini. You were the one who told us, right? It's an isosceles triangle. Yeah. No, Deepika. Who said? Both of you. Okay. Both of you.
Ma'am,
Yeah.
ma'am,
Yeah,
I
tell
do
me.
have a doubt, ma'am.
Yes. Deepika.
Ma'am,
I go out. Nandini will. Your HI and like this. This is 91 minute. 1 minute. Shreyas, I'm coming to you. Just a minute. This is 90. So you're saying this is 45, huh? No, not like that. See here. See here, if this is 100, these two sides are equal. So these two angles will be equal. Isosceles triangle property. When two sides are equal, the angles opposite to them are also equal. So in a triangle, when two sides are equal, opposite to this side is this angle. Opposite to this side is this angle. If these two sides are equal, these two angles are equal. So here in this triangle, these two sides are equal. So opposite to this side is this angle. Opposite to this side is this angle. These two angles are equal. This is 100. What is the remaining sum? 180 minus 100, 80. That will be shared equally between these two angles. 80 by 2, 40 here, 40 here. Now from here to here is 90. See, from here, radius till the tangent, which is 90 degrees. From the radius, see, this is the radius, OA is the radius. From the radius till the tangent, the angle is 90 degrees. And this one alone is 40. So the remaining angle, which is BAT, is 50 degrees. 90 minus 40, 50 degrees. All right. Yes, Shreyas.
ma'am, I think that we can prove this sum with a single theorem.
Using?
A single theorem, ma'am, that angle BAT, ma'am, angle OAB, angle AOB is equal to twice of angle BAT. With this theorem, I think we can prove the sum, ma'am.
No,
Because it lies on
1
the
minute.
same arc.
See, you have already thought about it. So you're doing it very fast. I need to, understand, comprehend what you're saying. 1 minute, 1 minute. This is 100, fine. Slowly. Yeah, next.
As angle AOB and angle BAT lie on the same arc AB, ma'am.
BAT, you're saying BAT, is it?
Yes, ma'am.
Ah.
They lie on the same arc AB, ma'am. So we can prove using that alternate segment theorem that angle AOB is equal to twice of angle BAT, so that angle BAT is equal to 50 degrees.
Correct. So for that, you cannot use it twice straight away. So for that, if you want to use the alternate segment theorem, what you have to do is you need to first take a point on the circumference. Okay, let me complete Shreyas, and then you ask me if I'm still not clear. Okay, you need to take a point on the circumference like this. You can call it P. You need to join A to P and B to P. Okay, now you can say that if this is 100 degrees, this one is 50 degrees. Because angle subtended by an arc at the center is double the angle. So if this is 100, this will be 50. Now because this is 50, this is also 50. This is what you're trying to say, right?
Can't A be the point on the circumference on the circle? Ma'am?
Which is the theorem you're trying to use?
And the same theorem which you just used.
Alternate segment theorem, is it?
Yes, ma'am.
Okay. Yes, BAT is a part of the, is one angle in the alternate segment theorem. BAT is one angle. Which is the other angle? AOB, is it?
Yes, ma'am.
Okay, so you're relating AOB and BAT, but you're saying twice BAT, correct?
Yes, ma'am.
Yeah, you can. It is a result. You're right. But from what I have explained to you in the class, what you can do is, you're right. You are right. But from how directly how we use the alternate segment theorem is with regard to this angle and the angle made by this chord at a point on the circumference, not in the center. You are right. You have understood the theorem, so you are able to manipulate it. I'm not saying you're wrong. You are correct. But the theorem goes like this. So this is the chord. You should take a point on the circumference. So I said call it P. Join A to P and B to P. Now this angle is 100. Okay, angle AOB is 100. So angle APB, AOB, APB. AOB is made by AB at the center. APB is made by AB on the circumference. So it's 50 degrees. Angle subtended by an arc at the center is double the angle subtended by the same arc at any point on the remaining part of the circle. So by that theorem, which we have learned in 9th standard, this is 50 degrees. Now by the alternate segment theorem, if this is 50, this is 50. You can use the alternate segment theorem, Shreyas, but you have to use it like this. Otherwise, you should mention the result that angle AOB is twice of angle BAT, and you can do it. Alternate segment theorem. But directly alternate segment, you are manipulating the alternate segment theorem like this. The result is actually this. Angle APB is equal to angle BAT is the result. But since APB is, half of, 1 minute. See here. The result is actually like this. Oh my God. Yeah, the result is like this. Angle APB, okay, is equal to angle BAT. This is the result. So what is APB? It is half of angle AOB. Half of angle AOB is equal to BAT. So on cross multiplying, you get angle AOB is equal to twice angle BAT. You're using this straight away. You're using this one. You're manipulating the result of the alternate segment theorem and using it. The result is APB is equal to BAT. That's how we have understood in the class. Now, what is APB? It is half of angle AOB because angle in the center is double. So circumference will be half of AOB. 9th standard theorem. So APB is nothing but half of angle AOB is equal to BAT. So on cross multiplying, you get AOB is equal to twice BAT and you're using this one. Okay. But still better would be this, like what I told you. Still better is this. Taking any a point anywhere, like this also you can take P and join the chord, the ends of the chord like this. And then say this is 100. So this is 50 by the theorem. And now this 50, so this is also 50 by the alternate segment theorem. See, now I was telling, and Priyanka, you were, like practicing how to make mehendi on your palm or whatever. Yeah. I'll let you do. Okay, here I've done using what we understood first, using the isosceles triangle property. So you can see here that in this triangle, OA is equal to OB, correct? Correct. So angle 1, I've marked here. See, angle 1 is equal to angle 2, correct? By the isosceles triangle property. Then AOB plus 1 plus 2 is equal to 180. Angle sum, Kanishka. Using angle sum property. But 1 is equal to 2, right? So instead of 2, you can say 1 itself. Because 1 and 2 are equal angles. So you can say 1 itself. So like that, you find angle 1 is equal to 40 degrees. Then radius perpendicular to tangent. And see how I have presented. See here, I'll explain what I've written here. OAT is 90. OAT, this full thing, OAT, this one is 90. What is OAT made up of? It's made up of angle 1 and angle BAT. What is OAT made up of? OAT is made up of two angles. OAT is this one, OAB plus BAT. That's what I've written here. So you shouldn't think how she's written this and suddenly this one. Continuation. I've written OAT is 90. And what is OAT? OAT is nothing but angle 1 plus BAT. Angle 1 plus BAT. And angle 1 is 40 degrees plus BAT is 90. So BAT is 50 degrees. I've written this and it's OAT is angle 1 plus angle BAT. Yeah. Try this. Yes, Shreyas, did I tell you something relevant to your question? Or you still have something in your mind?
No, ma'am.
Hold it. So. If QPT is 60 degrees. Oh, you're not able to see it clearly, Shreya? Oh. No, please tell me when you have trouble because I'm not seeing the board always. I'm not seeing the board always. You must tell me when you have trouble. Online students can see it clearly and you're seeing from there. Please tell me because sometimes I might see the board but not realize your problem. Because I'm just looking like this. Yeah, please let me know if you have any issue. Yeah. Okay, tell me the measure of angle. Tell me the measure of angle SPQ. How much? 120 degrees. The measure of angle SPQ is 120 degrees. Now use the alternate segment theorem. Which is the chord? Which is the chord?
SQ, ma'am.
SQ. Chord.
PR.
No, you can take PR as the chord, but that will not be useful. Yeah, chord.
PQ, ma'am.
PQ is the chord. PQ is the chord, correct. And how much is this angle? 120 degrees. So this one is equal to which angle in the minor segment?
Angle Q.
Was that Meera?
Yes, ma'am.
Angle Q, is it?
Angle R, ma'am.
Angle R, yeah. Okay, fine. Let me repeat the alternate segment theorem, children. See here. circle, chord, one endpoint of the chord, tangent through that point, angle between the chord and the tangent, chord and tangent, the angle between the chord and tangent. And this segment is the minor segment. This is the minor segment. What is, see here, this is the minor segment, this is the major segment. This is the major segment. So this is the minor segment. Now leave this one. Now since the angle is in the minor segment, take the alternate segment, the major segment. Take the alternate segment, the major segment. Okay, so this is the arc on the major segment. This is the arc of the major segment. Take any point on the arc. Join the ends of the chord to this point P. This angle is equal to this angle. That is what is the result by the alternate segment theory. I'll tell you again. Circle, chord, endpoint of the chord, tangent through the point Q. Okay, and this angle is the angle between the chord and the tangent. Angle between, like how we say the angle between the radius and the tangent is 90. Radius, tangent, 90 degrees. Like that, chord and tangent we are taking. We are taking the angle between the chord and the tangent. This angle. Okay, now this angle is in the major segment. This is the major segment. It's in the major segment. Leave that segment. Come to the alternate segment. This one. This is the arc, or this is the circumference of the minor segment. This is the circumference of the minor segment. This is the circumference of the alternate segment. Take any point on this. Join the ends of the chord to this point, P to R, Q to R. An angle is formed, PRQ. This angle is equal to this angle. Is the relationship between the, is the relationship by the alternate segment theorem. So here, this is 60 degrees. So by linear paraxium, this is 120 degrees. 120 degrees. Now this is the chord. Sorry. This is the chord. This is the chord. This is a tangent. This is 120. This is 120. Now leave that segment. This is the segment in which you have this angle. This angle is in this segment. Leave that one. Take the other segment. This is the circumference of the other segment. And you can see the point R on the circumference of the alternate segment. Join P to R, Q to R, the ends of the chord. Join P to R, Q to R. So this angle. So this angle is equal to this angle. So PRQ is equal to 120 degrees. All right, by the alternate segment theory. Yeah, find X. Okay, I think this you should understand by yourself, children. All right. All using what we have learned so far only, alternate segment theorem and this and that. Okay, I'll send these pictures. Help yourself. Next one. Yeah. Yes, children, I want the answer from you.
Ma'am, angle PAB is equal to 60 and AB is equal to 5.
Correct. Angle PAB is equal to 60 degrees and AB is equal to 5 centimeters. Now Shreyas has given the answer. Who can justify? He's right, but why is PAB? Okay.
Ma'am,
Okay. Correct. Then why is AB 5 centimeters?
Equilateral triangle.
equilateral triangle.
It's an equilateral triangle because every angle is, each angle of the triangle is 60 degrees. So it's an equilateral triangle. So all the sides are equal. Correct. Very good. Shreyas, Meera, very good. And Pranav Rajan, very good. So children, PA is equal to PB. PA is equal to PB. Isosceles triangle. Because why is PA is equal to PB? Tangents from an extended point of the circle, they are equal. So PA is equal to PB. That means PAB is an isosceles triangle. So that means this angle is equal to this angle. 180 minus 60 is 120. So these two will share it equally. So there will be 60 here and 60 here. Correct? Because these two angles are equal. Now all the three angles are 60 degrees. So it's an equilateral triangle. That means all the three sides are equal, which means AB is equal to 5 centimeters. Correct? That's all. So first you must say the tangents are equal. So by isosceles triangle property, these two angles are equal. I've called it X. I've called this one X. So X is 60 degrees. In triangle PAB, each angle is 60 degrees. Each angle is 60. So it's equilateral. Hence, AB is equal to 5 centimeters. Yeah, this I'll show the answer. One of you, I'll ask one of you to explain later. Please go through the answer. Is it right, children? Yes, Prana will tell us. Yes, Prana. Yeah, correct.
Can assume that the CR is equal to sigma just both the radius of the sector is sigma. And then repeat that the 6 ma'am. And then AR and AP both are equal plus radius and vectors. So can you put that on Y?
Yes, Shreya Shri, why is CR equal to CQ? Radius, not tangents from an external point of the circle. Radius, CR and see, this is R, okay? It's inside the other circle. Don't get confused. See, let's understand the figure. R is this point. This is the point R. This is the point Q. This is the point P. Correct? Yeah. So CR is equal to CQ. He's saying X. AR is equal to AP, Y, and then? Very good. Yeah. Next.
They are given AB equal to 5 centimeter. AB means which is AB is equal to AB is equal to 5 centimeter. Which is Y is equal to Y plus Z is equal to 5 centimeter.
Very good. Yeah.
Then BC is equal to 7 centimeter. So BC is like BQ plus BC Z plus X is equal to 7 centimeter.
Okay.
Then CH is equal to 6 centimeter.
Okay.
So X plus Y is equal to 6 centimeter.
Very good. Next.
Plus add.
Okay. Then we should add everything. Yeah. What do you get on adding?
Take
2x plus 2y plus 2z is equal to 18.
X plus Y plus Z is equal to 9.
2 is common is equal to 18. So x plus y plus z is equal to 9. Correct.
Like X plus Y is
X plus y is 6.
X plus Z is equal to
3. Very good. Very good. Z is 3. Now when z is 3, here we have z is 3. So that means x will be 7 minus 3, 4. And what else should you find? Y. Y you can find from anywhere y. So z is 3. Z is 3. So y will be 5 minus 3, 2. Very good. But we have to find only the circle with center A. The radius of the circle with center A. So we'll find only center A. So that is only y we have to find. We have to find only y. Have I found everything? Yeah, I found only y. So you have to find only y. So we got x plus y plus z is equal to 9, right? We have to find only y. So that means we'll substitute x plus z. What is x plus z? 7. X plus z is 7. Because we'll have to find only the radius of the circle with center A. A meaning y, center A meaning y we should find. So y meaning x plus z will substitute 7 plus y is equal to 9. So y is equal to 2. All right. Yeah. Yes, online children. Find the value of R. Okay, I want to say something. If this is for 1 mark, where you don't have to work, you just have to select the correct option. Remember this. The in radius is equal to in radius. Online students, use the emoji, raise your hand. Ram, Ananya, Rajeshwari, Sashmin, Meera, Priyashan, Shreyas, very good children. Very nice. Thank you. Yeah. So in radius, here you can see the in circle. So okay, what do you see here? You see a right triangle and it's in circle. You see a right triangle and it's in circle. So the in radius of the in circle in a right triangle is given by Sum of the legs minus hypotenuse by 2. Sum of the legs minus hypotenuse by 2. Legs are the sides containing the right angle. Yeah, tell me the answer now. Use this and tell me the answer. What's the end radius? Tell me the answer. Sum of the legs minus hypotenuse by 2. Online students, what's the answer?
Three centimeter, ma'am.
3, huh? Very good. Very good. Yes, it is 3. It is 3. 3. You can do it in another way also. You can find the semi-perimeter and subtract the hypotenuse from it. So you can see here. First find AC using Pythagoras theorem. First find AC using Pythagoras theorem, 25 centimeters. All of us know to find that. Okay. So AC is equal to 25 by Pythagoras theorem. All of us can find that. Next, the in radius is given by, see the legs. Normally this is how we mark. A and B are the legs. C is the hypotenuse. Normally we mark like that. In A, B and C, A, B are the legs. C is the hypotenuse. C is the hypotenuse. Okay, with that meaning, I have written the formula. With that meaning, that's why I told you already in words. Sum of the legs, A plus B, minus hypotenuse, minus C by 2. A and B are the legs, not any two sides. A and B are the legs. C is the hypotenuse. Sum of the legs minus hypotenuse by 2. Legs are A and B, hypotenuse is C. With that meaning, I've written this. So you can see here, in radius is equal to sum of the legs minus hypotenuse by 2. Legs are 24 and 7. Minus hypotenuse, we found 25. It's not given. We find using Pythagoras theorem by 2. When you work this, see, you should not cancel 2 ones are and 2 12s are, children. You should not cancel. You should add and divide by 2. You cannot cancel 2 ones are, 2 12s are. That's wrong. Should simplify this. So 24 minus 25 is minus 1. So 7 minus 1, 6. 6 by 2, 3. You can also do it like this. You can find the semi-perimeter 28 and the in radius is the semi-perimeter minus the hypotenuse. Semi-perimeter minus the hypotenuse. Now, if you're curious to know how do you know that, what is this formula like? See, I can come from here. You remember the results, that's enough. See, now you know that I told you the in radius is sum of the legs minus hypotenuse by 2. Okay, so how do you work this? A plus B plus C minus C minus C. Is this correct? Can I write A plus B minus C as A plus B plus C minus C by 2? Yeah, because A plus B. Then I'm adding C and I'm subtracting C. Then that minus C which is already there. Okay, see here. A plus B. 1 minute. Let's do it again. Is equal to A plus B minus C by 2. Okay, so I'm writing the same thing here. A plus B, I'm writing the same thing, minus C by 2. I'm writing the same thing. I've written the same thing. Now what I'm doing is I'm adding a C and I'm subtracting a C. So no change, no. Adding and subtracting. I'm giving you 100 rupees, I'm taking it back from you. So it's the same. So that's what so it's like this. So next step, R is equal to A plus B plus C. What is A plus B plus C? Semi-perimeter. I'm sorry, perimeter. Okay, no, I'll tell you, you can understand this yourself, children. Let me not trouble you like this. Is this correct? Is correct? Taking 2. You can do that. 2 is a common denominator. 2 is the common denominator. So a plus b plus c by 2 minus 2c by 2. So what is R? What is a plus b plus c by 2? Semi-perimeter. Minus 2c by 2 is minus c. That's what S minus C. That's what I wrote here. So everything has a derivation, just that we'll not do it because you have so much to remember. So you just leave all this. Remember like the sum of the legs minus hypotenuse by 2. Just remember this, that's all. You can find the in radius. The other way is you can find the semi-perimeter, 28. And the radius is semi-perimeter minus the hypotenuse. Semi-perimeter minus the hypotenuse. You can do it anyways. Right? Now, if you see here, children, can we prove that this is a square? Correct?
Yes, ma'am.
Correct? Correct? Then it's a rectangle and it's a square because radius. Adjacent sides are equal. Or you can say tangents from the external point of the circle are equal. Correct? So this is square. So that means all the sides are equal. So this is also R. This one is R, correct? And this one is also R. Then how much is this? 24 minus R. This is 24 minus R. How much is this?
7 minus 1.
7 minus R. How much is the this one? Hypotenuse 25. It's 25. Let me just take a point. What do I call it? Whatever, D. How much is AD?
24 minus 1.
24 minus R. How much is CD?
7 minus 1.
7 minus R. Now, what is the equation you can construct? What is AC?
24 minus R plus 7 minus R is equal to 20.
Very good. AC is equal to 25. What is AC? AD plus DC is equal to 25. What is AD? 24 minus R. And what is DC? 7 minus R is equal to 25. Okay, so 24 plus 7, how much? 31. Minus 2R is equal to 25. So 31 minus 25 is equal to 2R. So 6 is equal to 2R. R is equal to 6 by 2, 3 centimeters. So like this you can do. All right. Yeah. All these are from examination point of view. Alternate segment theorem, maybe you have not seen in school, but it will be very useful in the exam to answer questions. Nobody's learned that in school? Alternate segment theorem? Yeah. Now we are given that the area of the triangle is 189 centimeters square. All right, now what we're going to do is we're going to divide the whole triangle into 3 smaller triangles. Can we do that? Can we divide the whole triangle into 3 smaller triangles? What is the construction for that?
Yes.
Join OP.
O to Q, O to R, and O to.
Very good. join OP, join OQ, and join OR. Very good. Now we have divided the triangle into 3 smaller triangles. Online students, one of you name the 3 triangles. Name the 3 triangles. OT? Not equal, no? No, OT is not included. No. We've divided the whole triangle to 3 smaller triangles by joining OP, OQ, and OR. Don't see this one. This is there, but don't see this one. Yes, name the 3 triangles, children. Okay, no answer. Tell me. POR. POR. ORQ. QOR.
Sorry, no QP. Let's say OQP.
Okay, POQ. Correct? POQ. Why I didn't get any answer from you? Am I audible, children?
Yes, ma'am.
Okay, maybe my question was not clear. Fine. This was what I was trying to get from you. Step 1, join OP, join OQ, join OR to divide the triangle PQR into 3 smaller triangles. That's the first step. Now we are going to construct an equation from this. What is the equation? Area of triangle. Okay, let me not write so much in detail. Okay. Area of POQ, area of POQ, correct, plus area of QOR plus area of POR is equal to what? Is equal to area of the whole triangle PQR, correct? Area of the whole triangle PQR. The whole triangle is equal to the sum of the areas of the 3 small triangles. Now let's find the areas of these 3 triangles. POQ. POQ is half base into height. Half into base PQ into height. Draw. Now construct the altitudes. We know that this is the point of contact. This is the point of contact. Through the point of contact, if you join O, that's a radius. Through the point of contact. So it will be perpendicular to the tangent. You can see that the 3 sides of the triangle are tangential to the circle. PQ is a tangent to the circle. QR is a tangent to the circle. PR is also a tangent to the circle. The 3 sides of the triangle are tangential to the circle. So what do you do? So obviously, definitely you can mark the points of contact. So this is the point of contact. What should I call it? M. And this is a point of contact N. So through N radius. So 90 degrees. And this is already there. So this is 90. T is the point of contact and TO is the radius through the point of contact. It's 90. It's not marked 90, but we know it's 90 by the theorem. It's not marked, but we know it is 90 by the theorem. Now, half base into height, half into base PQ into altitude. What's the altitude? Huh? 1 minute. Online students.
OM.
Yeah.
OM.
Who's that? Priyasha?
Yes.
Very good, Priyasha. Priyasha, complete this. Plus.
Yes. QR. Base is QR.
Very good.
Altitude is OT.
Very good. Plus half into.
Half into PR.
Very good.
Into ON.
Very good. Is equal to, what is the area of triangle PQR given?
PQR base is QR.
No. We are already given the area of triangle PQR. How much is it?
189 centimeters square.
Yeah, is equal to 189. For PQR, you don't have to write half base into height. Why half base into height? That we already know the area is 189 is equal to 189. This is the equation. If you can write this, that's it. You'll get the answer. The idea here is when you look at this figure, the idea is you should divide the whole triangle into 3 smaller triangles by joining O to P, O to Q, and O to R. That's all. And then what's the equation? When you add the sum of the areas of the 3 small triangles is equal to the area of the big triangle. That's all. You should write that. Then half base into height. That you will get it. Now half into yeah. How much is what? PQ. Find PQ. We have to find PQ. Okay, we do not know PQ. So let PQ be there. PQ is PQ. Into how much is OM?
6 centimeter.
6 because radius.
Radius.
In plus half into how much is QR?
QR is not given.
Okay, so before that we have to do some kind of field work. Well, how much is OT, children? OT is 6. So OM is 6 and ON is also 6, correct? We should have done this earlier. Okay, let me I'll just clear this and come back here. I'll just clear this part. I'll come back to the figure. We should have done this earlier. Yeah, then it's given that OT is the radius or everything. ON is also 6. QT is 12. Then how much is QM? 12. No, I should have done this before I wrote the half base into height. I should have done this. Okay. QT is 12, so QM is also 12, correct? Tangents from an external point of the circle are equal. Then TR is 9. So NR is also 9, correct?
Yes.
Now what is not known? AM is not known. I'm sorry, PM and PN. So let's call it X. PM is X, so PN is also X because tangents from the same external point of the circle are equal. Is this understood? So how much is the base PQ? What is the base PQ? Huh? X plus 12. How much is the base QR? 20? 21. How much is the base PR? X plus 9. And what about the altitudes of the 3 triangles? 6. All of them 6. All the altitudes 6. So now let's continue with this one. So half into, I'll just write by 2 later. Okay, I'm not writing half. I'll write by 2 later. So PQ, how much is PQ? X plus 12. Into OM is 6. By 2 is 3. No, shall I write it? Half into base X plus 12 into the altitude 6 plus half into what's the base QR 21 into the altitude 6 plus half into base PR X plus 9 into the altitude 6 is equal to 189. Now everywhere 2 1s are 2 3s are 2 1s are 2 3s are 2 1s are 2 3s are. So here you get 3 into X plus 12 plus 21 into 3, 63 plus 3 into X plus 9 is equal to 189. So now we'll have to work this 3X plus 36 plus 63 plus 3X plus 27 is equal to 189. And on working this, you'll get the values 3X 36, 63, 3X 27 is equal to, yeah, we are here. So on working that, you'll get the value of X. X, you'll get X. And what's the question is, it's to find PQ. How much is PQ? PQ is what? X plus 12. X plus 12. So X plus 12, 22.5. All right, children. So when you look at this figure, the idea should occur to your head. You don't have to work this fully. The idea is divide the whole triangle into 3 smaller triangles and use the formula half base into height. Area of the big triangle is given to you. 189 is given to you. That's all. So you should recall the idea. You don't have to work the full answer. Just recall the idea. The rest is easy. So see, you have all this construction to do. So you'll have to join. You can see it here. All this is construction. Join OP, OQ, OR, and then the altitudes. This one. They are 90 because radius perpendicular to tangent. All this you must do. Is it clear, children? Okay, we'll continue tomorrow. Let's see. We'll continue with circles tomorrow, children, but we have not finished the session. Yeah. So this is Monfort School's half-yearly examination paper. Yeah, all if you take down this question in your book and tell me the answer. Ram, have we done this in the class, Ram? Do you remember anything like this done in the class here?
No.
No? If you're flipping your pages, I'm saying, can you recall? Don't see your book. Rajeshwari? Or if you get your trigonometric, meaning the book in which you worked the trigonometry tomorrow, okay? I'll show you the sum in your book. If you've been attending regularly. Yeah, get your book.
Ma'am,
Yeah.
ma'am, actually it's in our question paper, ma'am.
No, I have done this here in the class when I did trigonometry. That's what I'm trying to tell the children here. This is a very common question.
Oh.
Oh, not trigonometry, sorry, similar triangles. Similar triangles, not trigonometry. Yeah. Huh? Louder? If yeah, the angle can be different. I would have purposely intentionally changed the angle. Yeah. We have done? See that.
Ma'am, AC by B plus C.
AB by B plus C, is it?
AC by
Okay.
B plus C.
Okay. Just a minute. It will not be, because the speaker is in the projector. It won't be very audible, but I can just show you that sum. Can you see it here? Class, can you see the question here? The sixth one in this paper. There's a meeting recording. Question number 6, can you see? Express n in terms of m, x, and y. And it's a meeting recording of this year. You can see the date there, 24/11/2022. Meeting recording 1, the first class itself, 24/11/2022. Yeah. No, I was just trying to say, because I don't simply say I have done in the class, I have done in the class. I've really done it in the class. What I've done this year, what I've not done, I know. Yeah. Sorry? The paper I wrote in 2000, this was a test paper. 2016, that year, test 14. Question paper that year. I wrote this paper that year, but I taught the contents of this paper now, 24/11/2022. Yeah. All right, back to the class. Yeah. Somebody told me, I think Meera it was. Yes, Meera.
Yes, ma'am.
Yeah. So what read out, meaning I don't want the final result. Tell me your steps. How did you arrive at the answer?
We have to prove that these two triangles are congruent.
Congruent?
Sorry, similar.
Similar.
Yeah. MLK triangle should be congruent to similar to the triangle NPK. M is common, and angle M and angle N is equal to 46 degree. So by AA criteria, I have proved this as similar. So then I have written like ML by NP is equal to MK by NK is equal to LK by PK. So I have derived like A by X is equal to B plus C by C. So AC equal to B plus C into X. So X is equal to AC by B plus C.
Perfect. So you need to show that the two triangles. Pranav. No, I asked her to read from her book, so she did it out. Yeah. So triangle MLK is similar to triangle. Okay. How do we prove that they are similar? One angle is the common angle. This is the common angle in triangle NPK and MLK. In these two triangles, in this triangle NPK and the whole triangle MLK and the whole triangle MLK, correct? K is the common angle. This is the common angle. K is common. And then the small triangle has 46 degrees. The big triangle also has 46 degrees. So doubly criterion, the two triangles are similar to each other. Okay, so how do you name the triangles when they are similar? How do you name them in the correct order? So if you say K in the small triangle, it is K in the big triangle also, because that's a common angle. If you say K in the small triangle, it's K in the big triangle. And then if you say N in the small triangle, it is M in the big triangle, because 46, 46. Then the third angle, P, and the third angle, L. So this is the order. These two triangles are similar by AA similarity criteria. So in similar triangles, corresponding sides are proportional. In similar triangles, corresponding sides are proportional. So we have Kn by Km equal to Np by Ml equal to Kp by Kl. How much is Kn? C. Km, B plus C. Np, not required. You can ignore this one. Np by, what is it? Np, sorry. Np, I thought Np is what? X. By Ml is A. You can ignore this one because KP and KL we do not know. How much is KP? Don't know. KL, don't know. So leave that. Leave this ratio. Cross multiply this one. X into B plus C is equal to AC, correct? X into B plus C is equal to AC. So X is equal to AC by B plus C. Did you say this, Meera?
Yes, ma'am. AC by B plus C.
Perfect. This is what it is. You'll have to show that the two triangles are similar to each other. And then in similar triangles, corresponding sides are proportional. Write the proportion, substitute, cross multiply and get the expression for X. All right. We'll just wind up with this one, children. This is again another question from the same school paper, Montfort. Just a small one. Yeah. Find theta. The question is find theta. All right. If cos theta plus sin theta divided by cos theta minus sin theta is equal to 1 plus root 3 by 1 minus root 3. Since it's time, I'm going to work this. It's given that cos theta plus sin theta by cos theta minus sin theta is equal to 1 plus root 3 by 1 minus root 3. We need to find the value of theta. All right, this also I'll share the recording in which I've worked this in the class. I'll share the recording. So don't get confused. So that will be the recording in which you have the same sum. Okay. So this is what it is. So now you can divide both the sides by cos theta. Divide both the sides by cos theta, not both the sides, sorry. Divide the numerator and the denominator of the LHS by cos theta. Let me write and tell you. I'll tell you why to divide by cos theta also. So it's like this: cos theta plus sin theta divided by cos theta, the whole upon cos theta minus sin theta, the whole upon cos theta. You're dividing both the numerator and denominator by cos theta. All right, is equal to 1 plus root 3 by 1 minus root 3. Is equal to 1 plus root 3 by 1 minus root 3. See, we can do that now. Supposing you have a 45 by 81. What do? You reduce it to what? 5 by 9. How? Because you're dividing 45 by 9 and 81 by 9. Kanishka, look at the board. How do you get 45 by 81 is 5 by 9? How do you get that? Because you're dividing the numerator 45 by 9 and you're also dividing the denominator for 81 by 9. And that's how you get 45 by 9 is 5, 81 by 9 is 9. So what do we do here actually? You're dividing both the numerator and denominator by 9. I'm doing the same thing here. I'm dividing both the numerator and denominator by cos theta. Why cos theta? Because see here. So when you do that, it will be cos theta by cos theta. Will you not get 1 now? That's what we have here, 1 in the RHS. That's why. Then plus sin theta by cos theta, correct? Divided by cos theta by cos theta minus sin theta by cos theta is equal to 1 plus root 3 by 1 minus root 3. Now cos theta plus cos theta is 1. So 1 plus tan theta divided by 1 minus tan theta is equal to 1 plus root 3 by 1 minus root 3. Now compare both the sides. You can see here rational 1, 1, 1, 1. Compare both the sides. Can you see the plus sign, minus, minus. 1 plus tan theta, 1 plus root 3. 1 minus tan theta, 1 minus root 3. So on comparing both the sides, tan theta is equal to root 3. On comparing both the sides, tan theta is equal to root 3. And when is it root 3 in the tan table? Tan 60 degrees is root 3. Tan theta is root 3. On comparing both the sides, tan theta is root 3. And when is it root 3? Tan 60 is root 3. So on comparing again, theta is equal to 60 degrees. Theta is 60 degrees. Exactly the same sum we have done in the class in trigonometry. Everything, I'll show the recording for all these sums. Today I'll take the paper home and I'll share the recording for every sum which you have omitted in the paper. All right. It's okay, but I'm just trying to be safe by telling you that I have done all of this in the class. So it's just sufficient to revise what I teach you in the class. You don't have to do anything beyond that, because to remember this itself is a big task. Do only from the tuition notebook. That's more than enough. You should trust me. Is that fine, children? Online students? Lower your hands, class. Class, lower your hands. So at the end of the meeting, we have Ananya, Meera, Priyasha, Rajeshwari, Ram, and Shreyas. Sashmin is not there. All right. All right, children, online students. So that's it for today's session. Thank you so much. You may leave the call.
Thank you.
Yeah, thank you. Thank you, children.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, children.